Yes, sir.
So we discussed about linearity, example of linearity and non-linearity. Now regarding the property of additivity, on this slide you can see two examples. First example, the input is x of n. X1, output is y1, and in the second example, input is x2, output is y2. Now, if these two signals are fed together at the same time, that means sum of x1 and x2 at the input, then if the system has the property of additivity, then output should be sum of y1 and y2. So in homogeneity, you have learned when x, okay, let's say x1 of n provides the output y1 of n, then k times x of x1 of n should provide the output k times y1 of n. So this was homogeneity property. In this case, in case of additivity, let's assume k times x1n is producing k times y1n, and if we consider another input, let's say k, x2n produces k times y2n, then according to additivity property, k of x1 of n plus x2 of n should provide output from this system, which should be represented as k times y of n plus y2 of n. So when a system possesses these two properties, at least these two properties, then the system is termed as linear system. In this example, you can see it is a mixture. That means some low frequency signal is modulated or mixtured by a high frequency signal in order to produce the output. In this case, you cannot say the mixture, it is not following the additivity property because the output is a modulated signal. This signal, if it is a carrier signal, if you think of a carrier signal, certain fixed frequency, and input signal, if it is the low frequency signal, then output is a modulated signal, which, but we can say, which does not follow the additivity property. Probably it doesn't follow. Yes. So this is one example of non-additivity. Shift invariance is discussed in last class. Let's review that part. That means if the input sample is shifted by some number of samples, input signal, you can say, then corresponding output will also be shifted according to that number. That means if it is +5, then in this case, if it is +5, you have to consider +5 at the output. Similarly, if you consider negative value -2 at the input side, in this case at the output side, it will also be -2. That means because of shifting, either right shifting or left shifting, linear system input can be shifted right or can be shifted left. Only change that can be observed at the output is the corresponding shifting. Okay. If it is shifted again, if it is shifted right, then output will be shifted right. If the input is shifted left, it will be shifted left without changing the amplitude. Why is it called shift invariance? The term invariance means no change. That means due to the shifting, there won't be change in amplitude. That is important. Sometimes if it is asked, students only describe that right shifting produces right shifting, left shifting produces left shifting. But the important is due to this shifting, you won't observe any change in amplitude at the output side. So that's the full interpretation of shift invariance. Similar example, you can see input signal is shifted and corresponding shifting occurs at the output. Third property of linear system, desired property. system is linear, it should have additivity property, first property. It should have shift invariance property. Now, for example, a sinusoidal signal is fed. Sinusoidal signal and consider frequency of 100 kilohertz. Amplitude consider plus minus 1 volt. Now, at the output side, if you get a signal of say plus minus 2 volt, amplitude has become higher, double, but the frequency remains the same as the input frequency of the input signal, which is 100 kilohertz. That means only এটা তাহলে amplifier হিসেবে ওয়ার্ক করছে লিনিয়ার সিস্টেম অফ কোর্স amplifier এর একটা প্রপার্টি রয়ে গেছে সেটা হচ্ছে sinusoidal fidelity. That means sinusoidal signal its frequency should not be changed at the output. Amplitude may be changed, but frequency should be as it was at the input. So these three properties, when a system has all these three properties, then the system can be defined as a perfect linear system. You have home test. Go through this textbook, Digital Signal Processing, Fundamental and Applications. You can search the internet, or you can check your Google Classroom. Go through this section. There are some examples of this concept. Okay, let me discuss about one example. We have known about delta function. Now, if you consider impulses of equal amplitude, consider one, then this function is called step function, generally represented as y of n. All amplitudes are same. But if you understand delta function is shifting, then it won't be difficult for you to understand what should be the property of a step function also. So I recommend that you go through this section.
স্যার এই পর্যন্ত যা পড়ানো হচ্ছে আমরা কি সবকিছুই লি টার্নের বই ফলো করব?
Not necessarily. You can check some examples. In this case, okay, let me check it. Some part will be covered in that book, but not all. You need to check it. Most of the examples are prepared by me, so you will not get these examples. You will not get in any textbook. Then we can move on to the next lecture, lecture 3. This example is taken, this one is taken from a different book. You can check the first one also. All right, let's see these topics step by step. Superposition, convolution property, and the fifth one is the development of digital filter using convolution property. So first, let us see this one, what is meant by superposition. Yes. Okay. Before coming to superposition, let's consider this example. The first one, a special property of linear system. If you have a look on the first block, you can see two systems. System A is linear. System B is also linear. Now, two systems are cascaded. That means output of system A is fed to the input of system B. The two systems can be considered as a single system. That means this whole part is a single system, linear system with input and output. Now we can consider system A and system B is the subsystem of the whole system. The other way you can say two systems are making a third single system. Now if you connect, since system A is linear, system B is also linear. If you swap the position, that means bring B at the position of A, like as you can see, B is taken first and A is taken at the second stage. In this case, output of B, have a look, here output of B was Y of N. In this case, output of B is fed into the input of A. According to the commutative property, the system should provide same output as it was before. That means swapping the position doesn't make any change in the system for the whole system. Now, how can you demonstrate this example? Demonstration means in real life application. For example, if you consider some circuit or some component, say digital component can be amplifier. First system we consider as amplifier. Second system can be considered as filter. So first, what is happening in this case? A signal is fed, it is amplified, and amplified version is fed to the input of the filter. So amplified signal is filtered out. Filter will have some property, maybe say low pass filter. So it will eliminate high frequency signal, and at the output, low frequency signal, amplified signal will be obtained. Since the third system or whole system is this combined system is linear. Now we connect filter first. Fed the same signal. That means the same signal is fed to the system, but in this case only changes that filtering operation is done on the signal first. Then amplifier operation. There shouldn't be any change at output. যেহেতু সিস্টেমটা linear, output should provide identical information. But কখনো কখনো এটা ডিফারেন্স আসতেই পারে, it depends. Amplifier এটার লিনিয়ার জোন কতটুকু আছে, নরমালি অ্যাম্পলিফায়ার এর লিনিয়ার জোন থাকে, এরপরে গিয়ে ইনপুট আউটপুট রিলেশন যদি কনসিডার করা হয়, ইনপুট and output certain up to certain zone is linear. I'm talking about amplifier, linear amplifier. Certain input voltage, certain voltage ইনপুটে যদি একটা সিগন্যাল দেওয়া হয় এবং এটার ভোল্টেজ যদি ইনক্রিজ করা হয়, একটা সার্টেন লিমিট অবধি এটার আউটপুটটা লিনিয়ার থাকে, এরপরে এটা নন লিনিয়ার জোনে চলে যায়। Now we are considering linear amplifier in this case with characteristics of this type. Naturally, you will not get linear output if the input is beyond this voltage. তো এটার ক্ষেত্রে সেই একই প্রবলেম চলে আসবে। অনেক ক্ষেত্রে এমন হতে পারে যদি লিনিয়ার জোনে, প্র্যাকটিক্যালি লিনিয়ার জোনে যদি অ্যাম্পলিফায়ারটা না থাকে, সেক্ষেত্রে আউটপুটে ডিফারেন্স আসতে পারে। বাট ফর ইওর আন্ডারস্ট্যান্ডিং is enough to know that if commutative property is valid for the system, there shouldn't be any issue when the two systems, system A and system B, are swapped. Check the superposition concept. Superposition, you can see some sinusoidal signal. Have a look at this one, first signal, sinusoidal. In the second case, what is happening? Is varying, the amplitude is varying. And some of these two signal can be viewed as this third signal. Depending on the variation, it will depend on the third signal first. The superposition concept, that means two or more signal, in this case first signal, second signal, it can be viewed as, or the third signal you can say, this third signal can be viewed or assumed as the sum of these two signals. That means this, due to the superposition of this signal and this signal, third signal is obtained. Synthesis operation, decomposition operation, it was also discussed in the last class. আজকের ক্লাসে আমরা ফার্দার এক্সাম্পল দেখি। As you can see, a signal with some samples, specific samples can be considered. First, second, third, fourth, and fifth one. You also can see the index number 0 to 4. It can be decomposed. First signal can be considered as x1, second one, this way the last one. This is the concept of decomposition. Signal of 5 samples is decomposed. And the opposite operation, or if you think the opposite way, that means want to have the original signal back, it is termed as synthesis. So output, input, and impulse response relation can be represented through this equation. You can see the output, the system has the impulse response of Sn, then output is the convolution. This is convolution sign, star sign is convolution sign. Input signal is convolved with the impulse response, and the output is the resultant of this convolution. That means when you do the convolution of input with the impulse response, you get the output. This equation or this relation can be represented in a different way, which is called convolution sum. Now, how to find out the output from this convolution? It can be discussed step by step. In 3 steps, you can find out the output. So, first step is decomposition. Second step is related to impulse response, and third step is related to summation of impulse response. We can check it one by one. Can any of you answer what is the meaning of this part?
এটা ডেল্টা ফাংশন, রাইট শিফট ইসে যে পর্যন্ত স্যার।
So shifted delta function.
Shifted delta.
Telling right shifted. Okay, let's assume this is a shifted delta function. Then how can you represent this part? What is or how to define x of z?
এটা স্যার একটা সিম্পল সিগন্যাল স্যার, সিম্পল ফাংশন।
Impulse signal at instant sampling n equal to z. If you consider n equal to z, at that instant the signal will have some amplitude. It can be 1, it can be greater than or less than, depends. I mean 1 or it can be even less than 0 negative. So simply this is amplitude at certain instant n equal to that. Then that means so this part can be represented as shifted and scale delta function, isn't it? Only this part.
Yes, sir.
Since there is summation, that means the whole equation represents, whole equation in this case, input signal is sum of shifted and scale delta function. So that's the representation of input signal. Now, step 1, that means you can decompose. Decomposition concept is explained. The input signal can be decomposed. You can see the same example again, decomposition operation. Now, second step, as you have known that delta function produces impulse response. The other way you can say when input is delta, then output is termed as impulse response for the system, linear system. LS stands for linear system. It is also explained that shifted delta function will produce shifted equivalent shifting at the output or shifting of impulse response. So input has shifted delta function, output has shifted impulse response. Important to note is that equivalent shifting. Now, this term represents, as it was discussed also, shifted and scale delta function at the input will produce shifted and scaled impulse response at the output. So this is the case for one input sample or one impulse in this. You can consider either case. You also can consider this one as well. So this part represents only one sample of decomposed signal of the whole input signal. For example, this one is represented by x1 decomposed signal. So এভাবে আমরা decompose করব starting from x0, x1, x2 and it is summed up. That means we also need to sum up the output impulse responses. So output impulse response এটাকে যদি summed up করা হয়, that is the total output. So that's the concept of convolution. So this equation is termed also as convolution sum. Original compact form যেটা ছিল yn is the resultant of convolution of xn with impulse response. This representation and this representation are identical. Only difference that it is termed as convolution sum. Convolution has also one property, that is commutative property. It is better if I explain this property here, commutative. According to the commutative property of convolution, Hn also can be convolved with Xn. Doesn't matter. I will show the general equation on the next slide, but as I mentioned, it's better to have this one. So this is also true. Now, how to write this equation in terms of this convolution sum? Who can answer?
Sir, h of n minus j convolution xj j0 to m minus 1.
আবার বলবে?
স্যার মানে x h n minus j আর x j j0 থেকে স্যার m minus 1 পর্যন্ত।
No, actually what I meant, দেখো তুমি যেটা এক্সপ্লেন করলে সেটার সঙ্গে সেম প্রাইস। X instead of x of j, I can say it is h of j. H of j, and instead of h n minus j, I can say it is x of n minus j. That means replace করার ফলে আউটপুটটা সেমই থেকে যাবে। So in real operation you can consider either কোন প্যাডটাকে কনভলভ, কোন ইনপুটকে ইম্পালস রেসপন্স দিয়ে কনভলভ করার যে আউটপুট আর রেজাল্ট, ইম্পালস রেসপন্সকে ইনপুট দিয়ে কনভলিউশন অপারেশন করলে একই রেজাল্ট আসবে। There won't be any change. Now, one thing you need to understand, it will depends also number of samples. X of n, if we consider from 0 to n minus 1 number of samples, total n number of samples are there for the input signal, but for the impulse response the number is different. Impulse response, let's say m number of samples starting from 0 to m minus 1. Now when xn is convolved with hn, you need to know the total number of samples for the output. That can be found out when you know the total number of sample for the input n, total number of sample for the impulse response m. For output case, it will be m plus n minus 1. দুটো সামেশন করে একটা স্যাম্পল সাবট্রাক্ট করলে ভ্যালু আসবে। এবং in terms of indexing, যদি output, if you want to plot the output, since you know the total point, it should be started from 0 and total point will, last point will be just n plus n minus 2 আগের লজিক অ্যাপ্লাই করা। যেহেতু স্টার্টিং the 0 থেকে হচ্ছে টোটাল স্যাম্পল দেওয়া আছে, it will be m plus n minus 2. So that's the relation among স্যাম্পল। ইনপুটে কতগুলো স্যাম্পল রয়ে গেছে, ইম্পালস রেসপন্সে কতগুলো স্যাম্পল রয়ে গেছে, এটার উপরে বেস করে ডিপেন্ড করবে আউটপুটে কতগুলো স্যাম্পল আমরা পাবো। As I have mentioned, convolution is commutative. That means in this case A is convolved with B, which is equivalent to B is convolved with A. That means if you compare this commutative property of convolution, you can write or you can check it from previous example. xn convolved with ace of n is same as ace of n convolved with x of n. The first equation that was explained, convolution sum, can be expanded in this form. As you can see from here, the indexing is started for impulse response started from 0 up to m minus 1. So after expansion, you can write the equation this way. First term is the product of ace of 0, first sample of impulse response, x of n, then incremental value. In case of impulse samples of impulse response, you can see the values are in the ascending or incremental form. 0, 1, 2, 3, so on. And what is happening in case of input? First sample is x of n, then decrement by 1, x of n minus 1, again 1 decrement, x of n minus 2. Now, if you are given some values, you can plot it. For example, you are given ace of 0, ace of 1, ace of 2, either in terms of numerical values or plotting. And if you are given x of n minus 1, x of n minus 2, then in simple cases you can calculate output, but complex system এর জন্য তোমাকে অবশ্যই প্রোগ্রামিং বা সফটওয়্যারে হেল্প নিতে হবে, লাইক ম্যাটল্যাব। সিম্পল চারটা পাঁচটা ক্ষেত্রে হয়তো ম্যানুয়ালি অর ভিজুয়াল অবজারভেশন থেকে একটা প্লটিং করা পসিবল। Convolution sum can be implemented in filter. ফিল্টারের ক্ষেত্রে কিছু কনস্ট্যান্ট ভ্যালুস থাকে ফিল্টার ইম্পালস রেসপন্স থেকে আসে, যেটা এটাকে বলে ফিল্টার কোএফিসিয়েন্টস, which is related to this part. ইম্পালস রেসপন্স এর মধ্যে যে ভ্যালুস গুলো রয়ে গেছে বা ইম্পালস রেসপন্স রিলেটেড যে ভ্যালুস রয়ে গেছে সেটা, সো এগুলো দিয়ে ফিল্টার কোএফিসিয়েন্টস, এবং মোস্ট ক্ষেত্রে ফিল্টার কোএফিসিয়েন্টস গুলো কনস্ট্যান্ট ভ্যালু হয়ে থাকে। We can just represent pk instead of sk. That means impulse response হিসেবে কনসিডার না করে ফিল্টার কোএফিসিয়েন্টস আর কনস্ট্যান্ট হিসেবে কনসিডার করব। তো সেক্ষেত্রে আমরা ইকুয়েশনটাকে খানিকটা ডিফারেন্ট ফরম্যাটে রিপ্রেজেন্ট করব, লাইক দিস one. Only this part is changed here. I think time is over.
জি স্যার, আমাদের আরেকটা ক্লাস শুরু হয়ে গেছে।
আরেকটা ক্লাস শুরু হয়ে গেছে, so you can leave and yeah, we will have